I don't know how many of you are aware of this, but over on Odysee, you can use LBC, the library token, to promote a video. So if a lot of people like and promote your video, it can go to the top of a search. This video is the most supported Flat Earth video on Odysee. So when he says,
I'm Mitchell from Australia, and this is the #1 Flat Earth proof,
he's not just whistling Dixie. A lot of others are backing him up on it. This is not me punching down because I haven't beat up on a flat earther in a while and I just want to, although I do. This is the best of the best, the cream of the crop, the absolute best proof they have to offer. So let's look at it.
The premise to this starts with the sextant, and how we use the sextant in celestial navigation. We look directly through the sextant at the horizon. But if you live on a globe, what horizon are you actually looking at, Globers? Is it the Earth horizon? The water horizon? The horizontal reference plane? The visible horizon? How about the sensible horizon? The geodal horizon? Or the celestial horizon? Well, it's certainly not the geometric horizon, Earth curve.
I mean, we all know what the horizon is. We've known that for millennia.
Now, the globe-believing zealots tell us that their horizon is refracted. It's not an actual horizon.
Yeah, this guy's already so confused he literally doesn't know which way is up, and he doesn't even seem to realize it. Yes, light refracts through the atmosphere. We know this. This is easily demonstrated. That doesn't change the fact that you have no explanation for example, why you can only see the top of the Chicago skyline from across Lake Michigan.
So how do we have a tangent to a refracted horizon?
Complete nonsense question. He's just too dumb to realize it.
When you're viewing a star on a globe, how are we measuring an angle to the horizon?
You're not? Because viewing a star has nothing to do with the horizon?
If it's refracted, you will never ever get an angle to a refracted horizon. This is a major problem if you think you live on a globe, because celestial navigation would be impossible. So what have you done to keep your religion of a sphere Earth semi-plausible?
No one minds if I edit out these ridiculous pauses, right?
You've presupposed that that line, 90 degrees above your head, the zenith, actually runs to the center of your presupposed spherical Earth. And 90 degrees from that, you've made up a new horizon, the celestial horizon, which you say is a horizontal plane passing through the Earth's center, perpendicular to the zenith.
These are just concepts that make it easier to map out the stars from Earth's point of view. They don't actually exist. It's like a coordinate plane. You don't see actual latitude and longitude lines on the Earth or anything. And there's nothing that said they have to be in degrees instead of, say, radians or some other measurement. It's something we humans have made up to make it more convenient for us. It's a way we measure it. Just like there's nothing written in the cosmos about inches or centimeters. Do you understand how any of this works?
So, after presupposing all these things, you can now use your sextant. But globe believers, realizing that their visual horizon is refracted, can't yet look at the horizon through the sextant. So yet another horizon is needed to be fabricated. They use the bubble level in the sextant to create the artificial horizon, which we are then told is parallel to the celestial horizon, essentially taking away the curvature of the Earth.
No, we're making the base of the sextant perpendicular to the pull of gravity, just like a carpenter does when he uses his level. Do you honestly think carpenters are using the horizon when they make your floor level?
Because even globe believers know you cannot measure an angle to a curved surface.
You totally can, and I don't know why he thinks you can't. Other than basic geometry is beyond him or something.
Look at this. You're pretending you're living on a globe, but in order to measure angles, you need to pretend you're living on a flat plane.
No, we don't. We're just measuring a line perpendicular to the pull of gravity. That lets us take consistent measurements.
But there's one more step, and this is where it all falls apart for the globe. They then have to measure from the artificial horizon a dip angle down to the visual horizon.
Yes, because the Earth is curved! If the Earth were flat, you wouldn't need to. If you look straight from that line perpendicular to the pull of gravity on a flat Earth, you should be looking at the horizon. At least if the Earth is of any appreciable size. To have it dip down as far as we do to see the actual horizon would limit the flat Earth to being just a few miles in diameter. In fact, if you're holding your sextant 6 feet off the ground, the horizon is only going to be about 3.1 miles away. Why would that be the case, given we know the Earth is a lot larger than that? And why would you be able to see a more distant horizon by moving to a higher elevation? You know why on all those old sailing ships they'd have a crow's nest, a lookout tower where the barrelman, the guy with the spyglass, is? And how he shouts, "Land ho!" because he can see the land before anyone else. If the Earth were flat, there'd be no need for that. They'd just have the barrelman on the stern. And it was so important that they'd go out of their way to make it as tall as possible. Usually over 100 feet high, and sometimes as tall as 200 feet. If the deck is 15 feet above sea level, then you're only going to see about 4 3/4 miles. But at a 150-foot crow's nest, and at 165 feet, the barrelman can see out over 15 miles. Yeah, seems like you don't know the first thing about navigating on sailing ships.
May I present to you the number 1 flat Earth proof?
Yeah, go on. We can hardly wait.
All celestial bodies rise in the east, move in an apparent semicircular motion above the sky, and set in the west.
No, they don't. Not anywhere near all of them. Depending on where you live, Polaris doesn't. Crux, the Southern Cross, doesn't. If you're far enough north, in Canada, Alaska, and most of Europe and Russia, the bright star Vega never sets. It only sets when you're below that, down to about 51 degrees south, basically about the southern tip of South America. Any farther south than that, and you can't see Vega at all. It never rises. How is that possible on a flat Earth?
Now, relative to the horizon, if you look up, straight up above your head, 90 degrees, to where my drone is sitting, what will happen when that drone moves straight ahead in its own flat plane? It's not going to change altitude, it's just going to move straight ahead. From my observer point, what's going to happen? The angle is going to change. The drone has not changed altitude at all, it's just changed the distance from where I'm observing it. If it moves again, the angle changes again, down to 25 degrees there.
He goes on and on and on like that. Let's skip.
Now that we understand that the flat celestial plane above us presents itself as a dome to our perspective point, down here on the plane that we exist, we can understand how the celestial navigation actually works. Every star in the flat celestial plane has a position relative to our flat plane where it will be 90 degrees. This is called the geographical position, or the GP, of that star relative to our flat plane here on Earth. When the observer is at the GP of the star, it appears 90 degrees above their head.
It's called basic trigonometry. He seems to think it's something mystical, so he spends even more time on it. Skipping some more.
And I'll continue to point out that measuring angles to celestial bodies only works if we are on a flat plane.
Now, this is a question. Why? Why would it only work on a flat plane? For any given star, there's some place on the globe you can go to make that star directly above you. Why is this some kind of mystery? He never explains. Skip more basic trig.
To triangulate your actual position, you need to repeat these steps With other stars, your position is where all these areas of equal altitude meet. This is how celestial navigation works and has always worked on our flat level plane, using the celestial flat level plane.
Again, this guy knows nothing about celestial navigation. If you're sailing the Atlantic from Europe to the New World, Polaris is always going to be in view. You use that as north, and by keeping it the proper relative position to your ship, you can keep your bearing. By observing the angle of Polaris with your sextant, you can determine your latitude. That's what latitude is. The equator is 0 degrees latitude, not because Polaris is directly on the horizon. It's still going to be about 0.66 degrees above it. It's going to be directly on that line perpendicular to the pull of gravity. Now, his triangulation mess is not going to work, because as we all know, the stars move around in the sky as the Earth rotates, something that his model, a flat Earth and a flat plane of stars above it, does not and cannot explain. The way it actually works is, in order to determine your longitude, you use your star charts, find a bright star you know where it is, and measure it with your sextant. Then you can use it to determine your longitude if and only if you know what time it is. That is what's missing from his equation, the importance of timekeeping to celestial navigation. That's why accurate timepieces were so important, made more difficult by the fact that they couldn't use pendulums because the movement of the ocean would throw them off. And since there were no long-range communications, you couldn't ask anyone back home what time it was. So you needed to get a really accurate timepiece, set it to the proper time before you leave, and use it to determine your longitude. No triangulation, just a star, your chart, and the time. That is how celestial navigation works.
It is all flat. It is all the same level.
By the way, yes, he's using a relatively small lake as his example. Yes, if you do it on a small enough lake, the curvature isn't enough to see. But as has been demonstrated plenty of times, if it's long enough, yes, you absolutely do see it. This is a picture of high-tension power lines going over Lake Pontchartrain in southeastern Louisiana, which is about 25 miles across. You can see it for yourself if you drive by it on I-10. It's not just the fact that so many observations disprove the flat Earth, it's how much misinformation you have to spew to try and make it work. Small-scale measurements, not showing anywhere near the correct process for celestial navigation, bleeding on about refraction like it's some kind of conspiracy theory, and not an easily observed and measured phenomenon? Do they ever get anything right?
This is the killer blow to the globe. Not only is our world observably and obviously flat, it is measurably flat, as I'm about to show you in this next large-scale example. The rule of thumb with celestial navigation is to use stars over 15 degrees in elevation.
Skipping more crap.
If an observer was looking at Polaris from 15 degrees latitude, negative 60 degrees longitude, here near Dominica, they would measure 15 degrees to Polaris. If another observer was on 15 degrees north latitude and 120 degrees longitude, they would also observe an angle to Polaris of 15 degrees.
Yes, because they're at the same latitude. That's what latitude means. Longitude is irrelevant to how you see Polaris.
Because we know the distance between these 2 points are absolutely flat on the same circle of altitude, we can measure between them and we get 10,375 miles of flat Earth and ocean.
What? You know you're working with a map projection, right? That's not even the map as defined by flat earthers, where the North Pole is at the center of a disk. I don't even know what you think you're measuring there. You're using Google Maps or something and just sticking on points and lines with their tools and not even understanding what it is you're measuring. You're taking some freaky round trip over the North Pole for some weird reason. Measure it properly, and those 2 points are just under 4,000 miles apart.
And that's being nice to the globe. We can definitely see Polaris on the equator and even sometimes below the equator.
Yes, we know this. I went over it. In fact, Polaris will be visible to about 1.23 degrees south in latitude. So again, as with Vega, the question would be, why can't you see it at lower altitudes? You should know this, you're Australian. So when you're home, whenever you're in Australia, no matter how clear the night is, you cannot see Polaris. Why not? If the Earth were flat, you should be able to. And as I pointed out in another video, you actually see the moon upside down. Explain that one. And there are a lot of things you guys can see that we can't. Like the Southern Cross, the Jewel Box, the Magellanic Clouds, all sorts of constellations we don't get up north. You want proof the Earth is round? Just go outside on a clear night and look up.
Let's do this north to south now. If someone was at negative 75 latitude, looking at a star with a GP on the equator, we would be on the same area of equal altitude as someone looking at the same star from 75 degrees latitude. Knowing that between these 2 points has to be absolutely flat, let's measure between them. 10,375 miles again.
I don't really know where you're going with this, but your first measurement was way off, so let's see. It looks like you're using 180 degrees latitude, so I'll use that too, since it doesn't really matter. I got 10,353 miles, so close enough, I guess. Now, why don't you tell us what this means?
With an area of 84.5 million miles. Absolutely, measurably flat.
Okay, so you're not gonna explain, you're just gonna assert and keep going. Here we have 2 points separated by 150 degrees of latitude. Before, we had 2 points separated by 60 degrees of longitude. His claim was basically that since these two distances were the same, the Earth is flat. Of course, they aren't the same, he just sucks at using maps. But even if we steel-man this claim, it still doesn't work. If we pick the same degrees of longitude and latitude, 2 points separated by x degrees of longitude compared to 2 points separated by x degrees of latitude, we'd absolutely get the same number on a round Earth. It would not demonstrate a flat Earth. And before anyone says anything, yes, I thought about the idea of him being so dumb he mixed up west latitude and east latitude. Still doesn't work. No matter how you mix it up, you get points that are either 60 or 180 degrees of latitude apart, and that's not going to match 2 points separated by 150 degrees of longitude. Here's one to think about. Start at any point on the equator. Go straight to the North Pole and measure the distance you just went. It'll be something like 6,200 miles. Now turn right exactly 90 degrees and go the same distance. You're back at the equator. Now turn exactly 90 degrees to the right and go the same distance. You're back where you started. You just made an equilateral triangle even though you turned 90 degrees instead of 60. That's impossible on a flat surface and only possible on one that's curved. You don't even have to go that far. Navigate any real distance and you'll see non-Euclidean geometry all over the place, depending on the distances and how accurately you measure it. This is very important for things like air travel.
But it doesn't stop there. Look at this map with all the GPs of the navigational stars on them. And the reason why this is the #1 flat Earth proof is because using just one area of equal altitude proves that that large area that we're navigating on is absolutely flat. But by doing this multiple times to create multiple areas of equal altitude, we can literally measure our entire world as flat.
If you had as much capacity for abstract thought as the average sea slug, you'd see that making circles would do the same thing on a flat plane and on a sphere. See, I even wrapped it around a sphere for you. They're still circles, it still works. What you want to do is look at straight lines, specifically the shortest distance between 2 points. And as we saw earlier, you can get radically different results on a flat map than you do on a globe. And which one ends up being more accurate? The one you'll actually experience if you travel it? The globe, without exception! And remember, this is the best proof for a flat Earth. Not only according to this moron self-claim, but according to all the people who gave cryptocurrency on Odysee to support it as the best one. This is the best they can do. In fact, I guess you could say that the whole argument fell flat.
Just so you understand the enormity of this proof, we can literally measure our entire world as flat. We are living on a flat Earth.
You are living with a flat head. So thanks for watching. Please hit like and subscribe, leave a comment, and go to donate.veracity.tv to keep me doing what I do. And check out all the great content here, like this video selected just for you.